Okay, so on this third problem, what we're looking at is we've got a velocity vector. We've got dx dt here, we've got dy dt here, and it gives us an initial position. So quite honestly, when you look at this problem, very typical. They give us the stuff that we need to do this problem without any sort of issue. So on letter A, when we want to find the acceleration vector at time equals 2, all we have to do is take dx dt and take the derivative of that and plug in 2. And when we do that, we get negative 0.1033. Then we do the exact same thing for dy dt. Okay, I take the derivative of that and I plug in 2. Now again, our calculators will do that. That's why I'm not writing it out here. So I get 3.0277 or 3.028. There's your acceleration vector on letter A. Letter B wants to know what is the total distance traveled on the interval from 1.8 to 2. Well, remember, our total distance traveled is just the integral from A to B of dx dt squared plus dy dt squared, and then we take the square root of all that, and we've got a dt on the end. When you put that into your calculator, if you do it correctly, you get 0.360 for letter B. For letter C, I want the x-coordinate of the position of the particle at time equals 1. Well, in order to find that, I've got to take my initial x value, and then I'm going to add that to the integral from when that occurs, so that's at time equals 2, to where we want it, that's at time equals 1, and then we just do of dx dt. When I do that, so I plug that into my calculator, and I just put that in real quick, and I get 3.395. So that is the x-coordinate of the position of the particle at that particular time. Now at time equals d, there's a lot of different, or on this one, there's a lot of different ways you can actually go about doing this problem. Okay, it says at time equals t, at time t equals the square root of 7 pi divided by 2. The line tangent to the path of the particle is horizontal. Find the particle's speed at time t equals the square root of 7 pi divided by 2. Now, in order to find the particle's speed, what you would do is you would say, okay, I am going to use my speed function, dx dt squared plus dy dt squared, but, and this is where this gets a little bit tricky, in order for the line to be horizontal, what we would say is that, because that gives us the slope of our tangent line, if the top is equal to 0, then that means that that is going to be a horizontal tangent line. So in this case, we take 0 and we plug that in for our dy dt. Now that's only true at this given instant. So what I really have here is just dx dt squared, and then I take the square root of that, and I'm going to plug in the square root of 7 pi divided by 2. Well, when I plug that into this particular problem, what I get is positive 0.159. And so that is my speed. Now, I also need to determine the direction the particle is moving, to the left or to the right. So what I have to do is take this and plug it into dx dt. And strangely enough, I get negative 0.159, which means, because I want to know it's moving to the left or to the right, because that number is negative for dx dt, I say that it is moving to the left. Now again, this one's a little bit weird on the particle's speed, but that's where the first point comes from. And then the other point comes from saying that it moves to the left due to the fact that dx dt is negative at that time. Hopefully that made sense on this problem. This one I thought was pretty easy. Letter D, a little bit tough, but not awful. So hopefully that all made sense. If you have any questions on that one, please let me know.